Greetings of the day. This is the final review presentation of minor project 2EC703 under the Department of Electronics and Communication Engineering, Institute of Technology, Nirma University. The project title is Gesture-Based Computer Control System. Myself Akshat Baheti, 19BEC008, along with Dev Patwa, 19BEC024, developed this project under the guidance of Dr. Sachin Gajjar. These are the presentation outlines. First of all, we will see the prologue, then motivation, then objective, then what are the problem statements, what are the problems in this particular project which led us to develop this project, what are the approaches we used to develop this project, then we have the scope of work, then what are the timelines we followed, then we have the literature review, and or we can say the literature survey which we followed or reviewed. Then we have the flowchart and the block diagrams, and then further we have the software requirements. This is a software based project, so we have the software requirements. It do not have a hardware requirements as such. Then we will look forward for the conclusion and the future work, and in the end we will see for the simulation. First of all, we have the prologue. As we can see, the world is moving towards the augmented reality and using the Bluetooth and wireless technologies. So this project proposes a AI virtual mouse which uses a hand gesture techniques between the computer and between the person, so that we can easily communicate between devices and the human using just hand gestures, which is also known as the human computer interactions. In this project, we will be tracking the fingertips and tracking and recognizing the hand gesture using the built-in camera or the web camera, and performing the mouse cursors and another functionalities such as volume controlling. Now we have the motivation why we led to this project. It has been generation that since humans are been using hand gestures for communicating in human society, like shaking of hand, thumbs up means okay, thumbs down means not okay. So instead of doing the verbal conversation, we are just using the hand gestures, and we can communicate very easily and effectively. So why not use this with the devices? So humans and devices can also interact using the hand gesture. So the initial setup includes just the low-cost USB web cameras that can be used for providing the input to the system, and we have 4 steps to capture such and recognize the hand gesture. First of all is the frame capturing and image processing, then region extracting and the feature matching. Then we have the objective. What is the main objective of the proposed AI virtual mouse system is to develop an alternative. Alternative means another solution to regularize and standardize the traditional mouse system to perform the control of the mouse function. For example, left click, right click, scrolling functions, and other things achieved with the help of the webcam camera. Just the hardware requirements of this are the web cameras. The problem statements. The problem statement process that this proposed AI virtual mouse system can be used to overcome problems in real world, such as we can see that world has very much affected from the COVID-19 pandemic. So after the COVID-19, everyone is afraid to use or touch the device which was used earlier by another person. So in such case, a touchless environment is very much appreciated. So the proposed AI virtual mouse can be used to overcome these problems, since hand gestures and hand tips detection is used to control the PC mouse function by using the webcam or a built-in camera. These are the approach, or we can say the methodology we used to capture or recognize the hand gesture. First of all, the camera used in the AI virtual mouse system, then the capturing the video and processing, virtual screen matching rectangular region for moving through the window, then detecting which finger is up and performing the particular mouse function. Mouse function depending on the hand gestures and hand tip detection using computer vision. We will see in the simulation part that what are the hand gestures we are using to do the left click and volume control. This is the scope of work. There are some already related works carried out in the virtual mouse scenario, but also using the color tips in the hands of the gesture recognition. But they are no more accurate in mouse functions. They are using the hand gloves, or we can say data gloves. So it is not very much convenient for every users to use such type of hardware. But in our work, we don't need any types of data glove or any types of hardware equipment. We just need the naked hand and the hand gestures. These are the timelines we followed. In August 2022, which was our phase 1, we did the topic analysis literature survey in which industrial area this project would be most useful and the learning of the essential model. In September 2022, we did the virtual environmental setup, developing the hand tracking model. So why virtual environment setup? So there are we developed this in the Python script, and there are some libraries we use which was Python 3.8 dependent. So we developed a virtual environment setup of Python 3.8 and developed the hand tracking model. What hand tracking model did is it worked on two models. The first one is the palm detection, another one is hand landmark detection. The palm detection detects the uh, boundaries of the hand, and the hand detection landmarks uh, draw the 21 points on the hands and use the regression technique to summarize and to vectorize those points. Then in October 2022, which was our phase 2, we developed a cursor control module associated with the hand gestures. And in November 2022, we developed a computer control volume control module associated with the hand gestures. In December, the final phase was to integrate the cursor control and the volume control module so that we can perform multiple operations in using the one software only. We don't need different softwares. These are the basic literature reviews, like this virtual mouse using the hand gesture, that CC Farkas mouse controller system, and the Puthukariel and the Sundar hand gesture mouse interface system, which was used in 2013. This is the basic flowchart for cursor control. First of all, we will initialize the system and start video capturing from webcam. Then the capture frame using the webcam, and it provides the RGB images to the MediaPipe and OpenCV library. It detects the hands and hand tips using MediaPipe and OpenCV and draw hand landmarks and box around the hand. Then it will draw a rectangular box where this is the region of the PC window where we are going to use the mouse, and it detects which finger is up. So if the index finger is up and if middle finger are up, the mouse cursor moving around the window. The only if the index finger is up and if middle finger are up, the distance between them is less than 30 px, then it will perform the left click. Otherwise it will move the cursor in the window, and after all we will terminate the process. Then we have the flowchart for the volume control. In volume control, we will first initialize the system and start the video capturing from webcam. Then it captured the frame using the webcam and hand detection using MediaPipe and OpenCV library. It then detect the pinky finger. If the pinky finger is up, then only it will set the volume, or else if the pinky finger is not up, then it will detect the vector distance between the thumb and index finger, and it converts distance to volume percentage. And then further, only if the pinky finger is up, then only it will set the volume. We will show it in the simulation part. These are the basic software requirements. Laptop with minimum specifications, Python 3.8.xx version. X refers to don't cares. Then important Python libraries are CV2, MediaPipe, AutoPy, NumPy, Pandas, 6 GB internal RAM, i3 5th generation for smooth process flow, and camera with good resolution. This is the final integrated version in which we have integrated cursor plus volume control simulation. These are the 21 hand landmarks of the media pipe library. It mark those landmarks using the hand landmark model, and we can easily find vector distance between these 21 points easily, and we can detect every hand. As we discussed, this media pipe library is working using hand and palm detection model, so it can recognize your gestures, and it will point out all the points and connect them using the linear regression. So what are the conclusion of the project? This project is presenting program that allow the user to perform hand gestures in a very easy and convenient manner, and these can operate in real life and personal computer with a low camera cost, and it does not require a very high requirements and high definition cameras to detect or record hand gesture. Specifically, these types of things work can be have a motive of basically to automate the things in our system or our surroundings, where we go for a touchless environment, and they are so much reliable. Furthermore, the proposed gesture-based computer control system has some limitations, such as difficulties in detecting both hands simultaneously. It underperforms when a person has small hands, but the further optimizations can be helpful for doing this, and these limitations will be overcome in the future work. These type of projects are used in the medical environments, where you can easily develop a touchless environment, and in any other industrial environment where people are afraid to touch the devices, touch each other. So in such scenario, we can use such projects. These are the basic references we used for developing our program. The most important was the J. Katona, the review of human computer interaction, virtual reality research. Then we have DL Quam, DH Liu, SU Dudhani, KP Vinay, and L Thomas, virtual mouse using hand gestures. Now let's move towards the simulation part. So here we are at our simulation part. We have integrated.py, which will be uh, depending on this hand.py. What this hand.py will do, it will track our hands and do the regression techniques as we discussed earlier. So you can see I have written the volume controlling. Then we have hand detections as well. Then combining both of them. Then about the index finger and mouse cursor control. Let's run this program. It takes several seconds to run. As it will execute, it will pop up a window. See, so you can see that it pop up a window. And if I bring my index finger here, so you can see that volume set is off because I haven't used my thumb or the pinky finger, and I can easily track the cursor with my tip of the index finger. So now if you see that here speakers volumes are 100%, so I will try to reduce the volume. So you can see I'm trying to reduce the volume, but it is not triggering the speaker volumes. So to trigger this, we have a threshold of pinky finger. So as I turn on the pinky finger, you can see in the right bottom corner, the speakers are turning uh, volume high and volume low. And similarly, I can at the same time I can control the cursors as well, and I can maximize using the left click. Whenever I do this, it left clicks I use the middle finger, and for example, I want to minimize, so I will just do this and it gets minimized. So here is the basics of our program, and this is how it simulates. Thank you so much. My name is Akshat Baheti, 19BEC008, along with Dev Patwa, 19BEC024. Thank you.